Hello and welcome to the Spatial Structures Movers and Shakers interview series as we look ahead to the IASS Annual Symposium and Spatial Structures Conference, organised by the University of Surrey and taking place virtually in August 2021. My name is Mark Richardson and today I'm joined by Boris Reyher, who is a director at Schlaich Bergermann Partner, a structural engineering and consulting firm. Boris has completed projects ranging from signature highway bridges, footbridges, lightweight roof structures, concrete shells, office and residential buildings, through to high-rises and artwork projects. Boris has a special focus on innovative solutions, including a novel materials such as infra-lightweight concrete and carbon concrete. Boris, thanks very much for taking the time to join us today.
Well, thank you, Mark. It's a great honor to be here and to be able to speak within this series.
It's a real pleasure to have you on the Movers and Shakers interview series, Boris. Thank you again for joining us. We begin by asking our guests about the period of lockdown. How has that been for you personally in Germany?
I think we've been rather lucky from my personal perspective. As an office with about 200 people in the office, we have had, as far as I know, only one case of an infection. Despite all the news about high numbers and personal fates of people having gotten infected and even died, our business has been so far fortunately not been so negatively affected. And I even see some, every crisis maybe also has kind of a catalytic function in that it brings about certain things and it accelerates certain things like, remote work, like what we're doing right now, interviewing, speaking with each other from different places in the world has become quite natural. So maybe even the crisis has, some positive aspects, even though, of course, I appreciate, I acknowledge that many people have really suffered from it. But personally, and from our office perspective, it has not been as bad as you might have expected it.
Well, thanks very much for sharing that answer, Boris. That was very insightful. And as we alluded to, you are the director of SBP. Could you tell us a little bit more about the organisation and some of the projects it's involved in?
Yeah, well, I'm actually one of the directors of SBP, not the only one. Fortunately, because we are a medium-sized company with 200 mostly engineers, but also technicians, physicists, designers, and some mechanical engineers, for example. Well, the office was started in 1980 by Jörg Schlaich and Rudolf Bergermann, who also gave their names to the company, obviously, coming out of the office of Fritz Leonhard, which is another famous post-war engineer in Germany. And they started their own practice in 1980 with a handful of people. And by now, as I mentioned, we're almost 200. We have grown. We have also spread across the globe. We have now 7 offices. The original office is in Stuttgart in southern Germany, where Jörg Schlaich had his professorship at the university. And yeah, we have a strong focus. We are structural engineers who are focusing on spatial structures, lightweight structures, and generally innovative and creative work in the field of structural engineering. We also have tight links to the academic world through Mike Schleich's professorship at Berlin, and that's why I'm also personally very much involved in the interface between research and application of research results in practice, such as novel concretes, for example, or working with carbon as a tensile element.
And that's really great to hear. Thank you for sharing that with us, Boris, and also very exciting to hear about the growth of Schlaich Bergermann Partners over time. Sounds like it's been a great success. Maybe you could tell us about a research paper or a project that you are currently working on that's linked to spatial structures.
Yeah, well, I'm working on several things in parallel, but one of the most interesting things I'm working on now is maybe not so interesting in terms of the structural form, but it is very interesting in terms of the material because it involves a very lightweight concrete, which we call infra-lightweight concrete. and it's an industrial or a commercial project with a commercial retailer as a client. So a company that looks very much to the economy of its projects. Nonetheless, they have committed with us to design a supermarket building with external walls of concrete that weighs less than 800 kilograms per cubic meter, so less than a third of normal concrete, and that gives it the quality of thermal insulation. And actually, what makes this project special is that we're right now expecting a special permission from the authorities for the use of this concrete in a firewall, which is, I think, a first in the world that such a lightweight concrete as a structural material has been approved for a firewall with, special tests and approvals that we had to go through. It was a very onerous process, but we're very close to the end, and within the next weeks we're expecting the formal approval, and the site has already started. So this is to me personally very exciting, because it's really bringing research results into reality in order to improve the technology and improve the structures that we're designing, that we're building, and also to make things more simple again, to build monolithically rather than having different materials glued together as in a normal wall that you would do, with a load-bearing layer and then thermal insulation glued on. So all of that is now redundant with this new material.
Yeah, sounds like a very innovative approach to building there, Boris, and very excited to see the evolution of that particular product. So yeah, thanks for sharing that with us. Well, we're now going to move on to the middle section of our presentation, which is entitled Your Space, Your Structure. So at this point, I hand over the presentation rights to Boris, who'll be taking us through a presentation on a topic of personal interest to him for the next 15 minutes or so. So over to you, Boris.
Okay, Mark, thanks very much. I have compiled a number of projects that I've been involved in recently that we've been doing from the Berlin office, and I've called this compilation A Passion for Spatial Structures. And the underlying theme, if you wish, will be, how engineers can creatively come up with new ideas or transform existing ideas for new applications. And within, the motto of the IASS conference, Inspiring the Next Generation, I hope I can give a few examples, maybe how engineering, creativity, engineering design, engineering work can spark some enthusiasm, hopefully. I'm starting with a subject that is linked to concrete shells, and I've called it Concrete Shells Revisited, because of course concrete shells have been around for a long time. They have been very fashionable a while ago. They have become less fashionable in recent years, and so the question in this chapter of my presentation is, what can we take from the history of concrete shells and bring it into the current world and the current times, and what transformations can we use to take benefit of the existing principles and experiences that have been around for a long time in engineering. For example, in this very elegant and really amazing concrete shell by Felix Candela in Mexico, which is only 5 or 7 centimeters thick. So you kind of wonder, if they could do this in the 50s, why can't we? Why are we not doing this anymore today, with all the technology that we have? Or this shell by Eduardo Torroja in Spain from the 1930s, I believe, even older, and also very smart form, very optimized, very minimal material usage. Why don't we do this really anymore these days? So I want to show a project that we have been doing here in Berlin. The project is actually located in Berlin, and this is a picture from the competition phase, where together with a German-based architecture firm, we have come up with this idea. The brief was for 2 roofs for a tram station right in front of the Berlin main train station, which you can see in the background. And in the competition phase, we had the idea of being inspired by these classical forms of concrete shells and kind of transforming them into the modern times, and finding out what we can do with modern materials. And we came out with these two sort of mirrored structures with these wing shapes. So they have an abutment, if you wish, at the middle, and then they have these wings to the outside, and they're only supported at one side each by these columns. And of course, the key to shell action is double curvature. And to be honest, here double curvature only exists in certain regions, and in other regions it's more like a plate. It's more flat, it's less curvature. So what we did is we used a special concrete which is lightweight but high strength, and we also minimized the thickness in the design so that toward the edges it becomes very thin and very light, so that even though there's bending action involved, which of course is not what you're looking for in a shell, this will work in terms of the capacity and the stability and the deformations. And also what you can see in this picture is unfortunately in German, but it says here normal reinforcement and stainless steel reinforcement on the two lines of this, the two sides of this red line. And it means that in the very thin edge regions of the shell, there was not enough concrete cover, so we used reinforced. We used stainless steel reinforcement in order to make it work. And so this is also possible nowadays with modern materials. The construction of the shell was rather conventional, I would say. It was actually built by carpenters on a scaffolding and then coated, and then the reinforcement was placed. And you see these timber laths here, which are kind of rulers to get the concrete cover right on the top side. And then everything was concreted like in the old days, basically. And the shell now stands there, and it has become maybe a little landmark in the region of the main train station. You can see that in the background there's also a lot of more construction going on. And we're quite proud that with this little project we could contribute maybe a little bit to the revival of shells, even though, to be honest, it's not 100% shell, but the inspiration certainly came from the classical shell builders. Another example where we have been inspired by the theory and the construction of shells was a footbridge in southern Germany in the town of Ditzingen. And this picture may be a bit surprising. It's actually a plastic net in which you can buy oranges at the supermarket. And Mike Schlaich was playing around with this on his balcony one summer evening and thinking about form finding sort of in an experimental way with the things that he had in his house. And he was, of course, experimenting also with the analogy between tensile structures and compression shells. So what he was doing here, he was form finding a cable net, but with the purpose of designing the form of a new footbridge, which would be built in steel and which will be working compression, of course. So basically reversing the structural action of the tensile structure into a compression shell, and then transforming this kind of playful approach with the plastic net with modern computer methods such as Grasshopper and form finding software that we have developed and that we're using in the office. We were able to come out with kind of the equivalent structural form, a compression shell, where the shell actually is perforated, and the perforations indicate and visualize the flow of the membrane forces in the shell. So that was the underlying idea, to make basically visible in this shell the structural function and the structural lines. If you look, this is the top view, and you can also see this is a rather small footbridge. It connects two parts of company headquarter. The company is Trumpf. They make laser cutting machines for steel cutting. So this is another interesting link where the client that ordered the bridge actually was also part of the fabrication process, which I'll show in a minute. The interesting thing about when we started designing it, we wanted, of course, to make it as thin and as light as possible. So we came out with a 20mm thick steel plate for the shell, for the actual steel structure, which of course at the edges is a bit reinforced by stiffeners, but in the shell surface itself, it's only 20mm thick. And if you compare it to the shell of a chicken's egg, it's actually 10 times thinner, because if you take the length of a chicken egg and the average thickness of the shell of the egg, it's about a ratio of 125. And in our shell, with the 15-meter main span and the 20mm, it's actually a ratio of about 1,000. So our bridge is, we're kind of proud, we made it even better than the shell of an egg. And as I said, the company Trumpf, they make these big laser cutting machines. And they took the stainless steel plates of 20mm thickness, and from our design, they cut out these holes to make the perforation. And then these plates were taken to another company, which is actually a shipbuilding company that has a lot of experience in bending plates. And there's a little video here, which I'm going to show, and it shows how the process of bending the shell is worked. It's really rather mechanical, it's rather manual. It's a guy with hydraulic press and some jacks, and he has a lot of experience, and he just goes about the whole day with these rulers that he's holding to the plate and just bends it about until it has the desired form. So a lot of manual labor, or very low-tech labor, but a lot of experience in working these plates. So you see now the jack comes, the compression comes down and bends the plate so that in the end it has the desired shop geometry. With the pre-fabricated plates, they were welded together and then trial assembled, so that later on the construction site they would fit. Then they were brought to the construction site and welded together to the final structure. And another detail is that in addition to the lateral areas of the bridge, we also perforated the walkway, which of course is a bit difficult, because you need a smooth and a closed walkway so that people don't get stuck with their feet or with their high heels in the perforation. So we devised these little glass plugs. I think it was 17,000 in total. Each of them sits in a little drilling through the 20mm steel plate, and then these glass plugs were surrounded with the coating of the walkway. And you see these guys here sitting on the structure. They had to glue in these 17,000 glass plugs, and I think it took them a couple of days to do this. But in the end, the result was really nice. And these glass plugs actually have a function of carrying the light and guiding the light. So when you're standing under the bridge, it's really nice image. So this is the moment when the completed bridge was lifted into place and put down on the supports. And it was also given a very transparent and low reflection parapet to emphasize the lightness. Here's the underside view. You see the 17,000 drillings with the glass plugs in the walkway. So it's quite a nice picture, I would say. And at night, it's also illuminated from the underside. And here finally you see a very proud Mike Schlaich, who has received his German Bridge Construction Award, of course, as a representative of the whole team who has been working on this structure, on this project for a number of months. Going on to another project, which is also related to cable net structures. Again, there, nobody needs to reinvent the wheel. Cable net structures have been around for a very long time. There are numerous examples, for example, the arena in Raleigh, which is a very fine example of a cable net which is pre-stressed against the concrete edge girder, and then the concrete edge girder is supported on the facade columns. There are modern forms also, like the London Velodrome, where we were also involved as part of the contractors team with the shop design and optimization, and helping the contractor and expedition engineers to deliver this design. And from that inspiration, we were, we got some ideas for a competition which we participated together with Craft Architects in a competition for the covering of an existing historic ice rink in the town of Wernigerode in the Harz region in central Germany. So a mountainous region where winter sport has always been a strong factor. And this existing ice rink was to be covered with a new lightweight roof. And we knew we wanted to do something very lightweight, so using cable nets and membranes. And we started out by, going really down to the fundamentals and thinking about structural form, like a saddle shape, in order to generate geometric stiffness. We researched different forms of cable nets with geometries of different geometries of edge girders, and how the pre-stressing ratios can be found in order to get a bending moment free edge girder, then bringing it into space. This is an image that maybe is related to the Raleigh Arena roof. But of course, we wanted a roof without any corner columns. So we wanted to have an edge girder, which is only supported at the ends and spans 3 over 80 meters. So it's not quite easy to get this to work. You need to be a bit creative. You need to be a bit patient. You need to do a lot of research. In the end, we came out with this design. So a steel edge girder supported on 2 abutments, which are linked in the underground with pre-stressed concrete beams, and then a free spanning structure above, which consists of this curved steel boxes, then a cable net with thin stainless steel cables, and finally a PDFE glass membrane to cover it all. And then the steel structure went up, and this was 2017. And also, of course, it's very important to get the details right and to get the details clean, to think about how the directions of the cables and the connections of the cables and the nodes and even the welds of the membrane will affect and inform the appearance of the structure. So we think together with the architects, it was quite successful in really designing a clean and convincing structure. And yeah, it's now transformed this ice rink into an all year round venue for sports events and all sorts of festivities. The final chapter of my short presentation deals with art and engineering, because art is, of course, I would say, a discipline that deals with inspiring people and sparking joy in people. And if you manage to combine art and engineering, it can be a true benefit for both. And I'm going to talk about a project that we did with the artist Christo from New York City, one of his biggest projects called the Mastaba. Of course, unfortunately, a few months ago, Christo has passed away. But his work. Some of his work is continues, and I'm going to talk about a project that we have done with him in the recent years, which is this big sculpture. It would have been, or it would be, if it gets constructed, the largest sculpture in the world. It's actually taller than the pyramids of Giza. It's 150 meter tall. Geometrical form. The mastaba is kind of a truncated pyramid. It's a typical architectonic form from the Arabic world, and in this case, it would be a sculpture that is covered with 400,000 oil barrels, so colored steel barrels, and that was the architect's idea. And he came to us to ask to help him realize it. So we did for him a feasibility study to find out what structural methods, what structural forms, what materials, what erection processes, and so on can be found to effectively and economically design such a large sculpture. So here you see again the dimensions. It's 300 meters by 230 meters in the base dimensions, and then 150 meters tall. So really a mega structure. And you can see here an image of a space frame, which is one of the solutions that we found and studied and really designed to a certain degree to make sure that the quantities and that all the feasibility and everything was guaranteed. There are several layers, there are several hierarchies in this structure. There's a main structure, which is a space frame, and on top of that is sitting a secondary structure, which is the support for the oil barrels, and then the oil barrels themselves are sitting in kind of clusters as a tertiary structure, which can be moved and can be rotated for inspection and maintenance and eventual replacement of these oil barrels. So it's a very detailed study that we did here, design. One part of it was also the erection process. So one of Christo's idea was that the whole sculpture should not be built like bottom up, like a building, but it should rather kind of grow out of the ground. So we devised this this lifting method where everything would be assembled flat on the ground and then finally lifted up into space with large hydraulic jacking towers. And of course now it's questionable whether it will get built, but who knows, it might still happen. In the meantime, before Christo's death, there was kind of a little demonstrator project that happened in London in 2018. Maybe some of the listeners will have seen it on the Serpentine Lake in Hyde Park. This is called the London Mastaba. And we were also involved in this project. It's of course a bit smaller. It's only 15 meters tall, and but there's also a spatial structure underneath. In this case, it's made out of scaffolding elements, and the special trick here is that it's sitting on a floating platform in the Serpentine Lake. So it's not sitting on a concrete slab, but on these floating cubes. And you can see here some technical drawings that we did. So there's a layer of plastic cubes that form kind of a large pontoon, and they're anchored on the pond with concrete anchors. And then on top of that sits a spatial frame of scaffolding, normal scaffolding elements. And here you see some photos from the installation process. So you see the painted barrels coming and getting assembled in lines and then lifted onto the space frame and fixed there. There's a nice color scheme. And finally it was there and it was swimming, and it was a funny sight to have this very colorful object sitting in the park. And then Christo came from New York to give the approval, and when the master comes and smiles, then you have done most things right. Talking about Christo, there's whole series of projects we have fortunately been able to do together, and a current one which is, despite his death, being realized at the moment, is the wrapped Arc de Triomphe in Paris. And some of my colleagues are actually now on site supervising the erection. We have spent the last 2 years developing a concept and design together with different contractors to realize this wrapping process. There's quite a lot of engineering involved in the substructure, and it's as I speak, it's being assembled in Paris. So in a few weeks, I think starting September 18, this will be finished and will be up for 2 weeks. So the lucky ones of us who are able to travel to Paris will be able to enjoy this. Okay, this is the end of my little show. I hope it was interesting enough. And yeah, back to Mark.
Boris, thanks so much for taking us through your presentation there. That was a wonderful tour of a very great number of subjects. We covered applications of shell structures, and it was great to see the inspiration of Felix Candela, obviously a member of the spatial structures community we've covered in several of our interviews. It was wonderful to see some excellent examples of cable net structures, and also the topic of art and engineering, and your work in collaboration with the late artist Christo. So thanks very much for sharing that with us. And I must say the example you shared of form finding using plastic nets was wonderful, and I can well imagine some academic colleagues who may wish to use that or inspire them in their teaching. So thank you very much for that.
Thank you, Mark.
Well, let's move on to the final section of our interview, Boris, which looks towards the future of spatial structures. And indeed, you touched on this in your presentation with respect to the 2021 conference and its theme of inspiring the next generation. What advice would you offer, Boris, to aspiring engineers or architects looking to enter the field of spatial structures?
Yeah, I would say dealing with spatial structures as an engineer has a great potential to develop your creativity, to play out your curiosity in finding new applications of existing ideas and existing experience. Because as I mentioned before, none of this is really invented by anyone today. The principles have been around for a long time. They're well understood. And I think the beauty of it and the task is really to take these ideas and take these solutions that are around and bring them in a different context, and apply them to a different context. And I think this is where really engineers can not just satisfy their own curiosity, but also maybe show others what is possible, and also, of course, talking about sustainability, which is one of our major tasks these days. We're talking about minimizing the use of materials, and lightweight structures and spatial structures, of course, are at the very core of this. To really use as little as possible to make a structure stand up and make it last. And so I think it's a fascinating field. You're also making forces visible, you're making physics visible. So this is something that should be, interesting for any engineering student or any practicing engineer. And the other thing is, I've been doing this for a number of years now, and I'm lucky enough to work in a team that is super motivated in this field and experienced. But you never stop learning, like every time in every project you're faced with a new situation and you're kind of forced to come up with new ideas. You never do the same thing twice. And that's another thing, it's so these simple ideas of a pre-stressed cable or a curved arch, they're so powerful, they're so simple, but they're so powerful that you can do a million things with them. And that's the beauty of it. And I think if we practicing engineers can bring that across in our projects, and talking about our work, I think we can really, get the attention of these young people that are maybe deciding now which direction they would want to go. And yeah, that's something that I would see as a central task for people in this field. to spark this enthusiasm in young people.
That's brilliant. Thanks for sharing that, Boris. Very passionate answer, and great to hear your thoughts on the subject. We also touched on what's going to be my next question, which is, what do you think are the most pressing challenges in the field of spatial structures with respect to some of the current global challenges we face?
Yeah. Well, I should think generally for all engineers and all people involved in the construction industry, of course, the climate crisis is one of the biggest concerns and the biggest tasks that we have to deal with in the future. And lightweight structures and spatial structures, certainly, as I just said, the reduction of material usage is a central element in improving the way we build. And spatial structures, of course, have this great potential to give us new answers. I think it's very important that we review the way we have been building in the last years, because I was talking about earlier how concrete shells, for example, have virtually disappeared from the markets. They've been replaced by structures which are 100 times heavier, and just involve a lot of concrete, because it used to be so cheap and that you could just pump in concrete into your flat slab until it was enough. I think this is something that we have to review. It's all maybe cost driven, and but we have all this technology at hand. And what I was showing today was, it was not state of the art in terms of the fabrication and erection processes. There are some people out there experimenting with printed structures and with fabric formwork for structures, really innovative stuff. If we can use all that and combine it with the knowledge of spatial structures that has been around for so long, we can really make a difference, and we can really bring about a shift in the construction industry. In spatial structures, and the knowledge about and the understanding of spatial structures can be a key here. We basically have just to revive this. We have to show with a few projects what is possible, and then demonstrate that it's possible to build in other ways, and it doesn't have to be the thick and heavy flat slab structure.
Some great ideas there, Boris. Thanks for sharing those with us. And thank you very much for your presentation and for joining us today. A quick reminder for those watching the Movers and Shakers interview series, registration for the 2021 conference is still open. So far, attendees from more than 40 different countries have registered for the event. Please head to the conference website for full details and information. And if you've enjoyed this video, or indeed any in the Movers and Shakers interview series, please remember to like, share and comment. All of your views and thoughts are very welcome. But Boris, it's been a pleasure speaking to you today and for giving us a great insight into your ongoing work in the spatial structures field. And thank you very much for being such a wonderful guest on the Movers and Shakers interview series. It was a real pleasure to speak to you.
Well, thank you so much, Mark. It's been a great pleasure for me too.
Okay.
And I'm looking forward to contributing to the conference soon.
Absolutely. We look forward to that too. So thank you for now, Boris, and speak to you soon.
Okay. Thank you.